Okay, good day. Gawin natin sa video na to, let us answer one random problem about a DC motor. So, ang question dito, so para alam na natin, no, ang topic natin ngayon, armature torque, shaft torque, kukunin natin yung flux sa motor, kukunin din naman natin yung rotational losses, and then the efficiency of the motor. So meron tayong, sabihin na natin four topics, no, na kukunin dito sa ating one problem. So let us read the problem. A 4-pole, 240 volts wave-connected shunt motor gives 11.19 kilowatts when running at 1,000 RPM and drawing armature and field currents of 50 and 1 ampere respectively. So sa first sentence pa lang ngayon, no, siguro, ilagay na natin yung mga makukuha nating given and diagram. So based naman sa nabasa nating sentence, we have a DC shunt motor. So let us prepare the diagram of our DC motor. Sa ating armature branch, nailagay natin dito ang armature resistance. Pero sige, no, basahin natin ulit. Isa-isahin natin yung given. So, a 4-pole, ilista natin sa ilalim yung mga hindi natin mailalagay sa diagram. So, there is a 4-pole or 4 ang poles ng ating motor. And then, 240 volts ang ating DC motor. So, syempre, kung ano ang rating ng ating motor, we will be assigning that as the source voltage. So the source voltage of our motor is 240 and then wave daw siya. So wave wound ang ating motor. I-take note na rin natin dito na ang kanyang parallel paths, no, kapag involved yung letter A sa formula natin, 2M. Nagbigay din daw ng output power yung motor natin ng 11.19 kilowatts or 11,190 watts. This motor is running at 1,000 RPM. Meron tayo dito. And then drawing an armature and field currents of 50 and 1 ampere respectively. This is our armature branch, no? Sa mga videos na pinapanood natin sa generator and motors, no? In this channel, ang armature branch natin ay nasa gitna, no? So dati, di ba sa generator, yung armature current natin lumalabas sa armature. So ngayon, papasok na siya dito sa ating armature. 50 amperes daw yung armature current and the field current is 1. So it has 540 conductors. So meron tayong Z, which is equal to 540. And then babanggitin na ngayon dito the armature resistance. The armature resistance is 0.1 and then there is a brush drop. So lagay natin dito yung point, no, to determine or to indicate us that there is a 1 volt brush drop. Per brush yun. So kapag kasi mayroong word na per brush or each brush, tina-times 2 natin, di ba? So ilista natin dito, we have a brush drop of 2 volts. And then, syempre, sa armature branch din naman natin, nandito ang back EMF. Okay. So, find the armature torque, the shaft torque, the flux per pole, the rotational losses, and the efficiency. Isa-isahin natin for letter A, we will be looking for the armature torque. So, di ba meron tayong formula, direct formula solving for the armature torque. Kung kabisado natin siya, that is the number of conductors, the number of poles, the number of flux, the armature current over 2 pi A. So let us check now if we can use this formula. If we are looking for the armature torque, yes, we have the Z, nakalista siya sa given natin. The number of poles, may problema tayo ngayon. We do not know the value of the flux. So sayang, di ba? So direct substitution na lang sana kasi meron tayong armature current and then the parallel flux. So lampasan natin yung formula because we cannot use this na hindi natin alam what is the value of the flux. So ano pa yung pwede natin gamitin when we are solving for the armature torque? Di ba ginagamit natin yung developed power in the armature? And ang value ng developed power natin in the armature is the product of EB and IA, which is equal to 2 pi times the speed times the armature torque over 60. So again, nasaan ang hinahanap natin? Si armature torque. Next, kung i-check ulit natin yung mga given, we do not have the value of EB. So parang ganun din pala sa first formula, no? Hindi natin pwedeng magamit kasi meron pang hindi tayo alam. So we have the armature current, binigay din naman ang speed. Pero kasi 'di ba, mas madaling hanapin kung si E-back ang nawawala kaysa kay Flux. Tama, engineers or tama, students? Kasi 'di ba sa ating shunt generators or sa ating mga DC generators and motors, gumagamit lang naman tayo ng KVL in order to find the EB. So let us use or let's have our look in this case. So para hindi tayo malito, let's look at this diagram. So nag-umpisa ang KVL natin sa source voltage. Dadaan siya sa voltage drop ni armature resistance. Kaya meron tayong IR, I armature, R armature. And then voltage drop sa brush. 'Di ba? Kaya nga dinrawing natin yung figure para hindi natin makalimutan sa KVL natin na merong brush drop. And then finally, voltage drop or the back EMF. And then this will be equal to 0. I think given kasi lahat, maliban sa EBAC, masosolve natin yung EBAC, di ba? But the VS from our diagram is 240. Yung current na dumadaloy sa armature branch, 50. The armature resistance is 0.1. The voltage drop is 2. And then we are looking for the EBAC. So dito pa lang, no, we can now solve for the EBAC. And after solving for the EBAC, meron na tayong chance to solve the question letter A. So the EBAC is 240 minus 50 times 0.1 minus 2. 233 volts. Okay. So therefore, substitute na natin ngayon yung mga values dito sa second formula na nilista natin and let us solve the torque na nasa armature. So the EBAC is 233. The armature current is 50. No? Tingin lang sa diagram. This is equal to 2 pi. Ang speed natin, so nilista din natin yan sa given, 1,000. We are looking for the armature torque. And then i-divide natin by 60. So finally, for our question letter A, masasagot na natin siya. So yung nasa kaliwa natin, 233 times 50, i-cross multiply natin si 60. And then lahat ng katabi ni armature torque, i-divide natin. So 2 pi times 1,000. 111.25. 111.25 Newton meter. So we now have the answer for letter A and that is our key answer. Next, kunin naman natin ngayon yung letter B, which is the shaft torque. So ano naman daw ngayon yung shaft torque? And engineers, di ba kapag shaft torque, we are dealing with the shaft, which is the output of our motor. So kung kanina, developed power ang ginamit natin sa armature torque, ang gamitin naman natin pala ngayon dito is the output power pagdating sa shaft torque. So yung output power naman pala natin, siya naman ngayon ang magiging 2 pi N and ang kapartner niya ng torque is yung nasa shaft, imbis na yung nasa armature. So I think given pa din naman kasi itong lahat na to maliban sa shaft torque. So nailista natin that the output power is 11,190. This is equal to 2 pi. Ang speed again is 1,000. We are looking for the shaft torque and then divided by 60. So ito ang magiging shaft torque natin. 11,190, i-multiply natin sa 60, and then i-divide natin lahat ng katabi ni shaft torque. So, 2 pi times 1,000. 106.86 Newton meter. So, this is our answer in letter B. So, check natin, no? In letter B, the answer is 106.9. So, tama pa rin naman. So, next for letter C, let us find the flux per pole. So, engineers, ano ang alam nating formula na naghahanap ng flux or gumagamit ng flux? The formula for our EBAC, di ba? Which is pounds over 60A. Di ba? Formula for the EBAC, that is equal to the number of poles, the flux, the speed, the number of conductors over 60, and the number of parallel paths. So let us now substitute again, no? Kasi nakuha na natin kanina that the EBAC is 233. Sa ating listahan ng mga given, we have the number of poles na 4. We are looking for the flux. Ang speed natin is 1,000. The number of conductors na ilista din naman natin sa given, 540 over 60. And na i-take note din naman natin sa given that we will be using 2M for the wave winding. The times 2, and what is the multiplier? Kung hindi babanggitin, understood 1. So, ayun yung value ng M natin kung hindi babanggitin sa problem. So, let us show our flux in milliweber. Or sa calculator natin, ipakita natin yung answer natin na merong times 10 raised to negative 3. So, ayun yung milli natin. So, sa 233, i-cross multiply natin si 60 tsaka si 2, yung dating nasa denominator ng right side. And then lahat ng katabi ni flux, i-divide natin. So, 4 times 1,000 times 540. So, pakita natin yung answer natin in milli times 10 raised to negative 3. So, ito, 12.94. So, 12.94 times 10 raised to negative 3 Weber. Or this is 12.94. Sige, sulat natin. 12.94 milli na. Yung times 10 raised to negative 3 can be written as small letter n. And in our key answer, nandun pa din ang tamang answer na 12.9 milliweber. Okay? So for our letter D question. For letter D question, find the rotational losses. And then for letter E, so kunin na natin magkasunod, let us solve for the efficiency. So paano naman pala natin ngayon kukunin ang rotational losses? Since we are dealing now with the power, so with a power na nasa motor, kailangan kabisado natin yung power flow niya. Diba? After magkaroon ng input power sa ating motor, magkakaroon ng unang loss. So ano ang unang loss na binabawas natin? Copper losses. Pero hindi ito ang hinahanap ng problem. Hinahanap sa atin yung rotational losses. After maibawas yung copper losses, doon papasok yung power developed in the armature, yung PDEF. Tama, engineers, no? So, dapat kabisado natin to. Kasi sa PDEF naman ngayon, doon mababawas ang hinahanap natin na rotational losses. And kapag naibawas na ang rotational losses, nandoon na yung output power ng ating motor. Kung gagawa natin ng equation yung part na to, sana naiintindihan natin, no? Sana naiintindihan natin siya, na kung gagawa natin siya ng equation, di ba, pinapakita natin dito na kapag daw si developed power, binawasan natin ng rotational power losses, ang matitira is the output power. And kung aayusin pa natin yan, engineers, no? Kung aayusin natin to, panatilihin natin sa kaliwa si developed power, ilipat natin si output, magiging minus output power siya. Ilipat natin yung rotational loss, eto, sa kanan, magiging positive. So meaning, meron pala tayong equation na kunin lang daw natin ang developed power, which is EBIA, i-minus lang natin yung output power. So, ito na yung losses natin sa rotational part, di ba? Ayan na yung rotational losses natin. And yung tatlong quantities na kailangan natin, alam na natin. So, reviewin lang natin. The EB is 233. The armature current sa ating diagram, 50. And the output power is 11,190. So, substitute lang pala natin. The EBAC is 233. The armature current is 50. And then the output power is 11,190. The 233 times 50 minus 11,190. So 460 watts. So ang rotational loss natin, napakita lang natin dito sa ating final answer for letter D is 460 watts. So mamaya na lang siguro natin to tingnan kung tama. And then for our final question, no, pinabisado na natin, for our final question, we are looking for the efficiency. The efficiency, the general formula is output power over the input power. Given ang output natin, di ba? Alam natin yan, 11,190. And how are we going to solve for the input power? So, pwede natin gamitin, di ba, yung source side? Kasi sa source side, nandoon yung input voltage at saka yung input current. Yung source voltage at saka yung source current. And sa DC formula natin, power is equal to voltage times current. Sige? So, syempre, di ba sa ating listahan, reviewin lang natin, the output power is 11,190 watts. The source voltage, para hindi tayo magkamali, make sure natin. So for our diagram, we have 240 source voltage, 50 armature current, and 1 shunt current or field current. So 240 ang VS natin. And then, ano ba ang KCL natin? Di ba sa KCL natin sa shunt motor, ang source current ay ang pinagsamang armature and field current or yung shunt current natin. So ano nga ulit yung armature current natin? Kung naalala ninyo, kakabalik lang natin doon sa ating diagram. 50 ang armature current. And sige, para mas malinawan kayo, no? 50 ang ating armature current. 1 ang ating shunt current. No? And in our motor, si source current na ang equal to the summation of our armature current and shunt current. So in this case, we can say that the source current is 51 amperes. Simply, direct substitution now, let us solve for our efficiency. The output power is 11,190. The input voltage is 240. The input current is 51. So, sige, i-times natin by 100%. 11,190 over 240 times 51 times 100. So this is our answer in percent. 91.42%. 91.42%. So let us check now no, kung tama ba si letter D and si letter E. So ayun na lang naman yung hindi natin chine-check. Letter D and letter E. 460 tsaka 91.42. So in our key answer, 460 and 91.4%. So I hope no this one problem, marami tayong natutunan on how to get the torque, how to get the flux no using the Pons over 60A. And then for letter C, rotational losses ba tama? For letter D, yung rotational losses. So dito na-review din natin yung power flow ng motor. And then finally for letter E, we have solved the efficiency of the motor.